In this video, we're going to take a look at an example of calculating a line integral over a vector field. So we're going to find the work done by this vector function f of xy equal to x squared I minus xyj in moving a particle along the quarter circle r of t equal to cosine of ti plus sine of tj from 0 to pi over 2. So this is exactly moving around the quarter circle from t equals 0 to t equals pi over 2 here around that quarter circle. Okay? And so how to do this? Well, a reminder that to calculate our integral over a curve C of f dot dr, this is the integral from a to b of f evaluated at r of t, our parametrization of our path, dotted with r prime of t dt. And this is how we calculate our line integral over a vector field. So to do this, to find our solution here, we need to calculate r prime of t. Right? R of t is cosine of t comma sine of t, so r prime is the derivative of cosine is negative sine. Derivative of sine is positive cosine. Okay, so we have r prime there. And we also need to find f evaluated at r of t. Well, f is x squared minus x squared I minus xyj. So our first component is x squared, which is cosine squared. Our second component is negative xy, so that is negative cosine times sine. All right. Now again, to do this, we need to calculate the integral from a to b of that, of f of r of t, dotted with r prime, and then integrate with respect to t. So this is all equal to, so our integral over c of f dot dr is equal to the integral from 0 to pi over 2 of the vector cosine squared comma negative cosine times sine dotted with the r prime, which is negative sine comma cosine dt. Okay, well, let's do that calculation then. This is the integral from 0 to pi over 2. And do the dot product. That is cosine squared of t times negative sine of t. So it's negative cosine squared of t times sine of t plus the second coordinates multiplied together. So it's a negative cosine squared of t sine of t dt. Okay, this is the integral from 0 to pi over 2 of negative 2 cosine squared of t sine of t dt. All right, well, how do we integrate that? We notice that negative sine of t is the derivative of cosine, so we can take u equal to cosine of t, du equal to negative sine of t dt. If u is cosine of t, and t is 0, then this implies that if t is 0, this implies that u is cosine of 0, which is 1. If t is pi over 2, this implies u is cosine of pi over 2, which is 0. So our bounds change to 1 to 0. of the integral of u squared du. Okay, and what is this? Well, we integrate that and we get, I left off a 2 there. So there should be a 2 there. And what do we get? Well, we get 2/3 u cubed evaluated from 1 to 0. This is 2/3 0 cubed minus 2/3 1 cubed. Or in other words, negative 2/3. And we have completed the problem. That's it for this video.